Hello, my friends of Hatray Labs. My name is Saul Montoya. Please welcome to this tutorial. This tutorial is a tutorial where we are going to run a reaction in Phreeqc. Okay, so we have done water speciation. We have done mixing of water, but now we are going to do a reaction, and then you are going to see how we can build a reaction in Phreeqc. So for that, you need a word processor, any word processor of Windows. Uh, might help. So okay, and now we are going to define the oops. Okay, we are going to run Phreeqc under Aquifer app. Okay, and in order to do that, every solution needs a title. In this case, is reaction of rainwater with sodium chloride and calcite. Okay, great. Okay, so solution, there is only one solution, solution one. Okay, units is in milligrams per liter. The pH is 4.5. The temperature is 25. The calcium is 0.384. Magnesium is 0.043. Sodium is 0.141. Potassium is 0.036. Okay, and then we have chloride 0.236, and then we have carbon. Okay, and this is 0.1, and this is, I don't know if that means that this notation that is in equilibrium with chloride with carbon dioxide. I don't know. Okay, you can see the Phreeqc documentation. We have sulfur 1.3. We have nitrogen -3, and nitrogen 5. Okay, reaction 1. Okay, and now we insert the sodium chloride, and this is 2. This is not a concentration. Okay, and calcite is 0.01. This is a factor, and the solution is these ones. Okay, sorry. Okay, the solutions are this one. Moles. Okay, and for example, the first reaction, it will add 0.25 times 2, 0.5 moles of sodium chloride. Okay, and 0.0025 moles of calcite. Okay, and for the last reaction, it will add 2 moles of 1 times 2, 2 moles of sodium chloride, and 0.01 moles of calcite. Okay, and now we type N. Where we are going, we save that. How we, okay, and then we save that as a file that say rainwater reaction .in. Okay, it needs to have the extension in, otherwise it won't be recognized by Aquifer app. Okay, now we can close it. Great. So now on your browser, you enter aquifer.hatarilabs.com, Okay, you sign in. Okay, you insert your, okay, you have to create an account. For example, this is my account and my password. Okay, and then I add a project. So this will be reaction, and this is rainwater. Okay, try to keep the number, the name of your file and the name of your project small, otherwise it will collapse. Okay, so reaction is a great name. Okay, upload, edit. Okay, we go to Phreeqc and then we open the file. Okay, where is in documents, and this is rainwater reaction. Okay, the file will appear here. Okay, what we have typed will appear here, the reaction and the moles. Okay, we go to setup, Phreeqc, and then we run. Okay, if no comments appear here, means that the file that you have created is all right. Okay, otherwise, if you have missed a character or you have inserted a wrong keyword, some errors will come. Okay, and then we compile that. Okay, we have the raw modeling. Okay, we have the raw output, but we have some tools and tables and graphics. Okay, so this is the original composition. Please look at the amount of calcium. It's really small. It's 10 to the molarity is 10 to the minus 6. Of chloride is 10 to the minus 6. And of sodium is 10 to the minus 6. Okay, I say that because we are going, for sodium chloride, we are going to add even 2 moles. Okay, so that is why these numbers will be highly, will, will differ, will change high. Um, Okay, the pH is 4.5, the electrical balance, the percent error is 20%, and the species distribution, we see that all the carbon is as a diluted CO2, all the calcium is as a calcium ion, all the chloride as a chloride ion, all the potassium is a potassium ion. Okay, it's pretty simple, the chemistry of the rainwater. Okay, but let's see what happens with the reactions. Okay, so we go to solution composition. Okay, so in the first reaction we have, okay, do you remember it was 0.25 times 2, so it's 0.5 moles of sodium chloride. Okay, so we have 5 and 5. Okay, and as well we have 0.01 times 0.25, so we have this of calcite that adds calcium to our, okay, while the magnesium in the nitrogen stays the same. Okay, let's see, and let's see for the last reaction that where we add 2 moles, these are the 2 moles of sodium chloride, and then we see also that the calcium has increased as well, no? Okay, on the description, we see that the pH has increased from 4 to 9.52, okay, 952, and the percent of error is 0, and the density is 1.0117. Let's see that for the last reaction, where by adding more calcite, the pH has increased, but in the order of 9, okay, hasn't changed that much. It hasn't changed to 10. Okay, and the density has increased from 0.017 to 0.072. Okay, and the percent error is 0. Okay, great. So on the species distribution, okay, for the first reaction, we see that the carbon that was mainly a CO2 is no longer a CO2. Okay, is as carbon, diluted carbon, or as a bicarbonate, or as sodium carbonate or something like that. Okay, calcium, the calcium stays the same mostly, and what we see big difference is on the carbon. Okay, let's see for the last one. Okay, let's see for the last one. We see, well, as well the same. Okay, and let's see about the saturated index. Okay, at the beginning, by on the first reaction, we see that the is still unsaturated in respect to anhydrite, aragonite, calcite, dolomite, and gypsum, for example. However, where we change it to number 4, when we change it to number 4, we see that is slightly saturated over aragonite and calcite, and as well, but still unsaturated with respect to gypsum. Okay, so that's it. This is an interesting example about the reaction of water, and how we can model reactions in Phreeqc. Okay, just to remember that we are Hatari Labs, and Hatari Labs is a platform for knowledge sharing in groundwater. And then we have hatarilabs.com. We have an e-commerce site where you can find a lot of diplomas, for example, in groundwater modeling, in SWAT, in Python with FlowPy. Some of them are asynchronous, some of them are online. We have courses as well, and then we have recorded webinars and and live webinars as well. Okay, so you can join, and then you can purchase our courses, diplomas. And remember that by purchasing our courses and diplomas, you are supporting our investigation, our research. Okay, my name is Saul Montoya from Hatari Labs. Please have a great day and see you in another webinar.